If you are watching this video, it is because you have probably used an Arduino board before, configured it, and loaded a program, using the Arduino development environment to perform some specific electronic task. You may even have used boards from manufacturers other than Arduino, such as boards based on the ESP32 chip, configured their resources, and loaded a program with the same Arduino IDE environment to take advantage of the connectivity features of this board. Starting from this interaction with the Arduino IDE, you can already have an idea of the minimum components that make up an IDE, or an integrated development environment. Among which we have a code editor component, where we can write our code or program. A compiler, which allows us to translate this code that we write in a high-level language, such as C++, into low-level code, or machine language. A loader, which allows us to transfer this code to the program memory of the device or development board that we are using. A debugger, as a functional correction tool for the codes we create. Communication tools between our development board and our development environment. Like serial monitors. Or serial plotters. Integration tools. As a library manager, which allows us to search, download, and install libraries developed by other people, and include them in our code, making programming easier. A board manager, which allows us to search, download, and install the necessary components to program boards of different types and manufacturers. However, you are wondering, is there any alternative to the Arduino IDE? That allows us to develop embedded electronic systems, and that has at least these mentioned components. Well, today, and from scratch, we will load our first program on an Arduino UNO compatible board, and also on an ESP32 board, using a tool known as Platformio. Like the Arduino, it is an open-source integrated development environment. However, will it be better than the Arduino IDE? Well, let's see. To install the Platformio tool, we will first install the Visual Studio Code, or Microsoft Optimized Code Editor. Then we will install the Platformio, as an extension of the Visual Studio Code. So in order of installation, first the Visual Studio Code, and then the Platformio. To install Visual Studio Code on our computer, we open the search engine of our choice. In the search bar we type download Visual Studio Code. We click on the Visual Studio link. On the download page, we find the options for Windows systems, for Linux systems, and for Mac. In my case I click on the one corresponding to Windows 10, or 11. We'll start the process of downloading the installation file. Once completed, in the Downloads folder, click on the executable file to start the installation. A message appears telling me that only my user will be able to use the Visual Studio Code on this machine. I click Accept. I accept the license agreement, and click Next. It tells me the path where the Visual Studio Code program will be installed. I click Next. Then it shows me the name of the folder with which it will be stored. I click on Next. I'm going to create a shortcut icon on the desktop, and click Next. Shows me the summary of the installation configuration. I click on Install. It is a very light code editor, so its installation will not take more than a minute with a good internet connection. When the installation is complete, I click Finish to run Visual Studio Code. And here we have the graphical interface of our program. To install the Platformio plugin, in the column of icons in the left corner, we open the Extensions option, and in the search bar we type Platform, and in the search results we can identify the extension corresponding to the Platformio IDE. We click on Install to start the installation process of our tool, which may take a few minutes to complete. While completing the download of the files to install, we can see that we are in version 3.3.3 of this platform, and that this platform is applicable for the development of embedded electronic systems, among which we can see that it can integrate platforms such as Arduino, the ESP32 framework, from the ExpressF company, platforms under FreeRTOS operating systems, or multitasking systems, among others. And when the installation of the Platformio core begins, we only must wait a couple of minutes. When the installation is complete, a message appears indicating that we must restart the Visual Studio Code, for which I will close the program and open it again from the shortcut on the desktop. We can see that in addition to the general icons of the Visual Studio Code, an additional icon was created for the Platform.io tool. If we enter this, the list of project tasks is displayed, and the platform's quick access list, where it presents us with multiple work options. In the lower horizontal bar, we find the house-shaped icon for the Platform.io Home tab. If we click on it, the Home tab is displayed, along with a vertical bar of options, in which we find the Project Management option. Here all the projects that we develop from now on will be listed, and from which we can manage them, like the Sketchbook Management tab that we already know in the Arduino environment, where we find all the codes generated up to that moment. An option for Project Inspection, to obtain a report with details of the project composition in the memory of the development board used. A library option, from which we can manage, for example, an installation of new libraries, developed by Arduino or by third parties, to include them in our project, very similar to what we already know as a library manager in our traditional Arduino development environment. A board option, in which we can find a constantly updated list of more than 800 board from different manufacturers with general details of each board, and which can be programmed using Platform.io. We see in front of each board the platform to which it belongs, thus differentiating the concept of platform from what is a physical development board. For example, if we talk about the Arduino UNO board, the Arduino Mega board, the DigiSpark board, they are different development boards, and each one has different microcontroller chips. However, all of these microcontrollers have the same hardware architecture, which groups all of these boards into the same family of microcontrollers with AVR architecture, a grouping that Platform.io defines as the Atmel AVR platform. So in the next tab we find the platform option, from which we can manage the installation of different platforms to work with Platform.io, such as the Atmel AVR platform, or Atmel SAM. Although we will not interact directly with this option, we will see later how this tab responds to the different actions that we carry out to program our development board. In this case we will use a UNO R3 development board compatible with Arduino, on which we will load our first program using Platform.io. And we find the Devices option, in which the devices or development boards that we connect to the USB ports of the computer will be listed. At the bottom we find an Input-Output interaction panel, in which we find a Problems tab, to detect problems with the work area of the Visual Studio Code program. An Output tab. A debugging console for our projects. A Terminal tab, which will be important for us, since it will act as what we surely already know as a serial monitor in the Arduino IDE environment. And a Port Forwarding tab, to be able to access our Visual Studio Code services, from anywhere on the internet through a specific logical port. To start our first project, we go to Home or Start, and in the Quick Access control, we click on New Project. In the Name field, we put a name for our project. I will call it in this case, My First Arduino Project. In the Board field, we look for the board that we are going to use, typing Arduino UNO, which is the board that I have available, and we select it. In the Framework field, we select the only available option, Arduino. We can leave the default location to save this project, which is usually located in the Documents folder, on a Windows system. And we click Finish. We must wait a couple of minutes while the project is created with its dependencies. I will select that I trust the authors of this project, and click Accept. Upon completing the creation of the project, a file called Platformio.ini is displayed, a very important configuration file, which is located within the Explorer option, and which now contains 3 configurations that we choose when creating the project. The platform, Atmel AVR in this case. The board, Arduino UNO in this case. And the framework, in this case corresponding to a development environment for Arduino. To open or hide the Project Explorer, we do it through this icon. In addition to the Explorer, we have the Search tab, where we can search for folders, files, or even words within the files. The tab to install Git, to keep track of software versions, even in collaborative work between several people. We have the Debug tab, with a group of tracking components to be able to debug our code, that is, to identify functional errors and correct them. In a future video we will explain how this debugging function is used in a code for Arduino, emphasizing the differences with respect to the debugging function provided by the Arduino IDE. The Extensions option, to find and install the necessary plugins or components in our Visual Studio Code editor. The Test option, to test the code. And the option corresponding to Platformio, which we are working on in this video. Below in the Settings icon, we find an important customization option, where we find the color of the theme for the interface, having the default dark theme that we see on the screen. Modern clear themes, just as you see on screen. And even scandalous red themes, among many others. Due to my preference, I will work with the modern dark theme, which is default for the Visual Studio Code graphical interface. In the lower horizontal bar, we find the code control panel of the Platformio tool, where we can see the Problems option, Warnings, Ports for forwarding, the Home tab for Platformio, the Compile or Verify code option, the Upload code to the board option, the Clean compilation option, the Code test option, the Serial monitor option, the New terminal option, the Swap project option. Since you can have multiple projects in the Explorer, however you must select which one you are working on. And the Port selection option where the development board to be programmed will be connected. If we select it, a list of device options will appear in the computer ports, so let's connect one end of the USB cable to the computer, and the other end to the UNO board. The list of options will be updated with the new board connected, indicating the logical port in which it is recognized by our operating system, in this case COM6. We select the port of the Arduino UNO board. And now we can see the COM port of our board indicated below. Then we go to the File Explorer, and in the folder list of our project, we go to the src folder, and we select the main.cpp file. CPP from the acronym C++. This is the main file where we can type our code, that is, equivalent to the startup sketch that we know in an Arduino environment. And where we can see the void setup and void loop methods, traditional in the Arduino framework. With one difference, it explicitly includes the Arduino.h library file, which, in the Arduino sketch, is included implicitly. This Arduino.h file contains the basic definitions and methods that we constantly use to program in an Arduino environment, such as digital write, digital read, methods related to hardware serial, among others. The initial script comes with some example instructions. We can delete them since they are only references when starting with this editor. We are going to quickly digitize the traditional code that we already know to blink an LED, the well-known blink code, for the LED incorporated into the board in digital pin number 13. To compile or verify this code, we can do it from the lower horizontal control bar, or we can go to the upper quick access bar, and click on Build. We can see the information resulting from the compilation in the Terminal tab of the Output panel. If any, the syntax errors of our code editor will be illustrated here, as well the distribution of the code in the available memories on the development board used in case of a successful compilation, like the Arduino development environment in its output pane. To upload the code to the board, we can do it with the Upload icon in the lower control bar, or we can go to the upper quick access bar, and click Upload. If the upload is successful, we can see the LED built into the Arduino UNO board flashing according to what we programmed. To learn how to use the Platformio serial monitor, we are going to momentarily comment on the instructions corresponding to the LED flashing. And in the void setup method, we are going to initialize the hardware serial interface with a speed of 115,200, just as we do in our well-known Arduino IDE environment. In the void loop method, and through this same serial interface, we are going to continuously transmit the millis method, a method that counts the time in milliseconds that has elapsed since the Arduino board is electrically started, and we place a delay of 1 millisecond between each transmission. We upload this code to the Arduino board. When the load on the board is complete, we can see the LED labeled on the board as TX, flashing quickly, since the board is continuously transmitting data to the computer. In the upper right control bar, we can start our serial monitor, for which we will begin to receive data in our Terminal tab, coming from our UNO development board. Now we see unrecognizable data without any meaning for us. This is because, if we move to the first data of our terminal, we can see that the serial monitor is configured with a transfer speed of 9600 baud, and in the code we edited we have configured a speed of 115,200 for the board interface, which is why the parts of the communication will not be understood. In the task panel, located in the lower right part, we find all the tasks carried out so far in Platform.io. The last of them corresponds to the execution of the serial monitor. Once we identify it, we can close it or terminate the process. If we go to the lower horizontal bar, we cannot see any option in the graphical interface to change the speed of the serial monitor to match it with the one our Arduino board has. So how do we change the speed of serial monitor in Platform.io? We previously discussed the importance of the Platformio.ini file in our project. We open this file in our Explorer. And with the monitor speed instruction, we can indicate the new speed we want, in this case 115,200 bauds. With the key combination Ctrl+S, we can save the changes to this file. We open the serial monitor again, and we can now see in the terminal the data sent from our board, in this case corresponding to the elapsed time in milliseconds or millis method. However, in all the exploration we have done so far of the Platform.io graphical interface, we have not seen how to illustrate this same serial monitor data graphically, such as the serial plotter tool that we already know in the Arduino IDE development environment. The reason is because there is not one so far. Platform.io does not have a built-in serial plotter, so we go to the extensions option of our Visual Studio, and look for a plugin such as the serial plotter, which says in its description that we can graph data received through the serial port in a dedicated pane or window, so I think it could serve what we want. We click on Install. In the details of this extension, it mentions that the line sent through the serial plotter must start with this symbol. It also tells us that it must include a name for the variable, a colon, followed by its value. And below he shows us an example code to transmit multiple variables to the serial monitor in a framework for Arduino. With this information, we are ready to go to our main.cpp file, and encode the transmission of our initial prompt or symbol. The variable name as VR1 and the colon. And the transmission of the millis method closing the line. We upload this code to the UNO board, and that's it. But where do we now see this data graphically? Well, if we go back to the details sheet of the serial plotter extension, and we go down to the last instructions, it tells us how to open the serial plotter. Telling us that we must open the command palette and write serial plotter, open pane, to open the plotting panel. Then we can go to the gear icon, and open the command palette option. We can also open it with this key combination for Windows, and for Mac. And in the text box that opens above, type serial plotter, and select open pane. And the plotter interface is displayed, in which we must select the port through which we will receive the data, and the speed at which it will be received. By clicking on Start, we can see the listed data arriving continuously, and at the bottom we can see the graph of the elapsed milliseconds, with the possibility of also zooming in on the graph, keeping in mind that in the extension specifications it is indicated that the graph update time is 25 milliseconds. So it would be advisable to ensure that the data sent by the Arduino board is transmitted with a time of at least 25 milliseconds between data. We can stop the graph when we don't need it. Now, if we go back to our main code file, how do we install and include a library in it? Just as we do in our well-known Arduino development environment. We go to the Start window, or Home of Platform.io, and here we enter the Libraries option. Here we can see a tab called Registry, for searching for new libraries, a tab that illustrates the installed libraries, so far none, a tab that shows us the libraries incorporated natively with the installation of the Platform.io, and a tab to update the libraries. In the Registration tab, we are going to look for the ultrasonic library. Yes, the one to manage the popular HC SR04 distance measuring, or obstacle detector module. We found 117 search results, and we scrolled through the first results to the library of the creator Eric Simoes. We identify in the right corner the compatibility of this library with the Arduino framework of our interest, and we click on the ultrasonic link to open it. Here we click on the Add to the Project button. And here we select which project we want to add it to, in this case the one we name as My First Program for Arduino. Up to this point, we can realize that a specific library, with a specific version, is added to a specific project. Unlike the Arduino IDE development environment, at least until the date of recording this video, in which a library in a specific version is added to the entire development environment or framework, so different sketches, or all of them, are forced to use the same version of the installed library. In the Platform.io environment, we can install different versions of the same library to different code projects, identifying an improvement of Platform.io with respect to the Arduino IDE. Then we click on Add to install it in this project. Once the installation is complete, the well-known Platform.ini file is automatically displayed, in which we can already see the inclusion of a new dependency corresponding to the new library. Once this is verified, we can go to the Home tab. We enter the library. Then to the Installed tab. And here we enter the library link, where we can see in the Examples tab, a code overview of how to use the library for Arduino. I'm going to copy this code from here, and in my main code tab, I'm going to paste it over the current code, of course without deleting the inclusion of the Arduino.h library. From this moment on, you can upload this code to the Arduino board, connect the module to the board, and verify its distance measurement in front of an object or obstacle, viewing the measured values in centimeters, in the Visual Studio Code terminal. Now let's load our first program on this board based on the ESP32 chip, a popular 30-pin development board, with Wi-Fi and Bluetooth wireless connection capabilities, which make it ideal for Internet of Things or IoT projects. For this we go to the home of Platform.io, we go to New Project, and we give a name to the project, in this case my first ESP32 program, then we select the model of the board, in this case we can select the model ESP32 dev module, from ESP32. In the framework option, we can find the ESP32, the Expressive company's own framework. Up to this point, we can identify that to program boards based on the ESP32 chip, there are two framework options. The Arduino framework, with which we obviously program the ESP32 boards from the Arduino IDE development environment. And a second framework, called ESP32, corresponding to the proprietary framework of the Expressive company, so, compared to the Arduino development environment, where we only manage the same framework, the Platform.io extension, in addition to allowing the Arduino framework for this type of boards, allows the use of the framework supplied directly by the ESP32 board manufacturer, which constitutes an important improvement of the Platform.io extension with respect to the Arduino IDE. We then select the Arduino framework for this case. We click Finish, and wait a few minutes while it installs the project dependencies. Once the project creation is complete, we go to the Platform tab, and as we had mentioned previously we have not had direct interaction with this section, however, we can see that it is being updated with the platforms that we are creating in the projects, in this case ESP32. If the new project we created does not automatically appear, in this case with the name My First ESP32 Program, you can go to the Home tab and click on Open Project. Here you can open the project's link, select the project we just created for the ESP32 board, and click Open Project. A new project will be added to the Explorer section, and of course, the Platform.ini configuration file will automatically open, this time, with the initial configuration of my new ESP32 board. So if we go to Explorer, then to the ESP32 project, open the src or source folder, and open the file for the main code, we can now edit our new code here. We connect the ESP32 board to our computer using the USB cable. We enter the popular blink code to blink the LED built into the board. Unlike the Arduino UNO board which has the LED built into pin 13, this ESP32 board has the LED built into pin 2. When finished, we upload this code to the board, and as we see in the results of the terminal, Platform.io automatically detects the port where the ESP32 board is located. Once we see the message, connecting, on the output terminal, it is at this moment where we must press for a couple of seconds the boot button labeled on the board, so that it allows us to start loading the program in its memory. This will start the loading process with an indicator in percentages. Upon successful completion of the load, we can now see the built-in blue LED on the ESP32 board, flashing according to the programmed code. Dear friends, a special greeting from Electronic Spot, and see you in the next video.